So this is M62, which is global climate change and the greenhouse effect. So basically, we looked at the indicators the other day in class, and that's kind of what these all are. So there's global change, there's global warming, and there's, I forget what this one is, global climate change. And so those are all the indicators that that you guys researched and presented in front of the class. So just make sure that you understand them. Hopefully after that research that you guys did that one day, that will help you. And we're going to talk about kind of, these are the indicators, but we're going to talk about what exactly is the greenhouse effect, what exactly is global warming, and how is it caused, or what potentially how it is caused. So if we look at this picture, this diagram, this is the greenhouse effect. So the greenhouse effect is not man-made. So that sometimes is confusing to people. Global warming is potentially accelerated because of stuff that we do as humans, but the greenhouse effect is completely natural. So basically what happens is as solar radiation comes in, it comes in as UVA, B, and C, and then a variety of other things. But the ozone helps to absorb a lot of that. But what ends up coming in through the ozone is a little bit of UVB and UVA rays. And so those are short wave radiation that comes in. And so once it hits the ground, it heats up the ground, and the ground is absorbing that energy. And then it re-radiates that energy back out as long wave radiation. And long wave radiation doesn't penetrate through the greenhouse gases. So as it comes in, as the short wave comes in, it goes through those greenhouse gases like CO2 and methane and nitrous oxide. But when it bounces back up, so radiates back out as long wave, it doesn't go through it. It kind of is absorbed. And so that's the greenhouse effect. So the same thing occurs like in your car, for example. If it's hot out, the radiation comes through your window. It's absorbed by the stuff inside your car. And then once that long wave is radiated out, it's blocked and trapped by the windows. And so your car gets really hot. Same thing with the greenhouse. And so that's why they call it the greenhouse effect, because it's very similar. Obviously, it's not a window or a glass, but it's the gases that we deem greenhouse gases. And they're the ones that trap this gas or trap the heat. And so understand what this diagram is showing. So it's basically showing kind of what I just described. Not all of the radiation comes in. So a lot of it is reflected by cloud cover. In times of increased volcanic activity, sunlight is blocked. During the fires last summer, sunlight was blocked. And then also it's reflected by a process called albedo, and that is from reflected off of polar ice caps. And so white surfaces reflect a lot of energy, as you might know if you've ever gone skiing or snowboarding and didn't put sunscreen on. There's a lot of reflection going on, and so you get an increase in a sunburn due to part of that. So just understand basically this model and understand what's going out or what's going on in this model. So without the greenhouse effect, we would not be able to survive on Earth. So Earth would be much different. We would have to be kind of concentrated along the equatorial region. We wouldn't probably be able to live, or be much colder here in Redding compared to how it is now without the greenhouse effect. So life as we know it would not exist, or would exist in different areas than we see it today without the greenhouse effect. Our average temperatures would be much colder. So the concern is this greenhouse effect. So these greenhouse gases. Well, the greenhouse gases are things that occur natural, but we can accelerate that by things that we do. And so just to give you some information, I think we went over this earlier this year, but the atmosphere is made up of 78% nitrogen and 21% oxygen. The leftover 1% is about 20 other gases and then a bunch of compounds. And so within that 1% are all these greenhouse gases. So they don't make up very much of the atmosphere, but they can be a big deal. And so if we look over here at the greenhouse gases, so definitely know this table. So these are the 5 main greenhouse gases. And then they're listed in order. So water vapor is the biggest greenhouse gas. A lot of people are surprised by that. But water vapor does hold a lot of heat. And so it's naturally occurring. We don't really change that. We don't really add to the atmospheric water vapor. But what we do add are the other four. So carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons, also known as CFCs. So these are things that we add, and they're in order of their concentration. So water vapor is the most, CFCs are the least. And then in the middle, it goes over global warming potential. So you can see water vapor doesn't really cause a lot of global warming potential. So it is a greenhouse gas by trapping heat, but not really a big impactor, even though there's quite a bit in the atmosphere. And then if we look at carbon dioxide only has a potential, these are all measured against carbon dioxide. So measured against carbon dioxide, we see it's 1. So, and then looking at methane is 25 times more, has more global warming potential than CO2. So that's quite a bit. But then if you look at CFCs down the list, 13,000 times more potential to trap heat than carbon dioxide. But if you look at how much there's very, very little CFCs. Whereas carbon dioxide, there's quite a few. And so that's why people are really concerned about carbon dioxide. And carbon dioxide is talked about all the time because it's super abundant in the atmosphere. And so that's the biggest influencer of greenhouse gas and global warming is basically CO2. So know those 5 greenhouse gases, and make sure you can list them in order. And they're all naturally occurring. So they all naturally occur, except for CFCs. CFCs are not naturally occurring. We use it in refrigerants. It's banned now. The Montreal Protocol kind of put a stop to that. But there are other things that we do use that are very similar. We use hydrochlorofluorocarbons. So they're very similar. They just have an extra hydrogen in there. And so those are still used today. So they're very, very similar. But the Montreal Protocol is trying to ban those as well. So moving down here, there are natural and anthropogenic causes of these greenhouse gases. So the natural sources, I kind of listed them here, summarize the next page or so. But volcanic eruptions can give off CO2. And obviously those are naturally occurring, depends on how many volcanic eruptions we have, but that is a contributor to CO2. And then decomposition and digestion. So decomposition, this could be in wetlands, this could be in bogs, digestion through animals. So if there's a high amount of oxygen, then there's going to be CO2 given off. If there's a low amount of oxygen, like in a swamp or bog, then you've got methane. And this goes for anything. When we talked about the landfills, same thing. So remember, if you stir it up, then you have high oxygen content. So you have CO2 being emitted. But if there's low oxygen, then you have CH4. You have methane. And what's interesting, and we'll bring up the cows again in the anthropogenic because we have livestock for feed. But cows and termites produce a lot of methane. Cows are kind of the number 1 methane producer. Termites are number 2. Because in their digestion, they have low oxygen. And so their digestion sources use low oxygen. And so it produces a lot of methane. And so that is a big contributor as well. And then denitrification, low oxygen levels, that contributes to nitrous oxides, so nitrates and nitrites into the atmosphere. And we learned that back with the systems when we looked at the nitrogen cycle. And then evapotranspiration. Evaporation is occurring because of heat. And then evapotranspiration, that is through the leaves of plants as they photosynthesize. And so that gives off water vapor. So that's a source of a greenhouse gas that's natural. So those are the 4 natural ways. And then on this page, it goes over the anthropogenic sources. So there's quite a few. There's fossil fuels. So we know that burning coal, oil, and natural gas produces carbon dioxide, methane, nitrous oxides. Coal is the biggest producer of these. Oil would be second. Natural gas is third. So that's why they consider natural gas a clean fossil fuel, even though it's not really clean. But they consider it to be cleaner. And then particulate matter is a big deal with fossil fuel burning. So you've got this soot, especially with coal and oil, and that particulate matter landing on white surfaces like snow can cause less albedo. So that is less reflection and more absorption. So you can see that can be a big deal, especially if, think about the soot settling onto maybe ice sheets. And so that would accelerate melting because now the snow is absorbing more energy, absorbing more heat, and melting faster than if it were whiter. So that is a big deal. And then agriculture, so livestock produces methane, fertilizers, nitrous oxides, and flood irrigation. Once again, that's kind of simulating a swamp or a bog. That would produce methane because that would be low oxygen content, especially if you think about like rice fields, rice paddies where they have water kind of just standing the whole time. So that is stuff's breaking down, and so that would create some methane production. And then deforestation. So there's carbon dioxide. If we burn the forests, particulates if we're burning like a slash and burn type of farming. And then there's methane, there's nitrous oxide. So pretty much everything except for the CFCs is produced with deforestation. And deforestation could be logging, but mainly I'm talking about burning, like a slash and burn type farming. And that goes on a lot. Deforestation is probably the biggest issue in developing countries right now with their farming practices. And then landfills, we talked about that with with methane, CH4. And then chemicals, and what's kind of interesting with that is there's some landfills that are actually using this methane, and they are taking that and using it for energy. If you went and toured the wastewater management facility, I found it kind of interesting that they take the methane that's produced, because once again, that's waste, kind of like landfill manure. So they've got, they're taking that methane and they're using it to heat up one of their pools to create digestion. And so I thought that was kind of really interesting. They had excess methane. So they said that they have like 60 to 70% leftover methane and they just burn it off. And so it'd be kind of cool. I talked to the guy. It'd be kind of cool if they could, in the future, possibly use that to power homes around the area, especially since it's just kind of a byproduct. They are using some, but not all of it. So I thought that was kind of interesting and kind of cool. And then the chemicals, this would be things that we use for refrigerants. So CFCs, like I said, the Montreal Protocol has banned CFCs, but we also use hydrochlorofluorocarbons, and those are still in use today. And so they're wanting to ban those and get them out of use by 2030. And that's kind of what I put over here. So the Montreal Protocol, it's basically reason, or it's the reason that they have it, is to phase out CFCs. And then developed countries, they are phasing out HCFC, which is the hydrochlorofluorocarbons, by 2030. And so that's really kind of cool. And then this last part, understand where each greenhouse gas is coming from. So this graph, or this figure, shows where they're coming from. So you see methane and where it's coming from, nitrous oxide, mostly ag, and then carbon dioxide, electricity, transportation, those are the big ones. So just kind of be familiar with that. Obviously, you don't need to learn the percentages, but know what the biggest contributors are. Methane's kind of all over the place, but the biggest one is natural gas and petroleum systems, and then gut bacteria, which is digestion. And then, just be familiar with them and be able to state where the biggest problem or the biggest reduction could occur, where we could reduce the amount put into the atmosphere. And that is it for M62.